From our previous lecture videos, we have already discussed the rotational kinematics, the definition of rotational motion in terms of the angular quantities like the angular position, angular velocity, and angular acceleration, as well as the motion at constant angular acceleration. And now, in this lecture video, i-discuss naman natin yung rotational dynamics. We have seen that force is the cause of accelerations. In terms of rotational motion naman, torques cause angular acceleration. Para mas maintindihan natin yung principle ng torque, let's consider this figure. This figure is a top view of a door that is hinged on the left. Ito yung hinge. And merong apat na forces na ipinapakita sa kanya, all of equal strength. Pare-pareho ng magnitude yung forces. Among all these four forces, alin kaya dito yung pinaka-effective na makabukas or makamove nung door? Makikita natin yung force 1 perpendicular dito sa door. Ito yung door and ito yung force 1. Force 1 will surely open the door. Mabubukas niya agad yung door. Pero yung force 2 is papunta dito. Kung mapupush yung door dito sa direction na to, hindi niya ma-open yung door. Yung force 3 naman will open also the door. Ito yung force 3. Kaya lang, hindi ganun kadali sa pagbukas ni force 1. Si force 4 naman, though perpendicular din siya dun sa door and it has the same magnitude as F1, pare-pareho sila lahat ng magnitude ng force. Kung susubukan natin yan in reality, mas mahihirapan tayong ibukas yung door kapag yung force ay ilalagay natin dito sa part na to. So the experience that pushing close to the hinge is not as effective as pushing at the outer edge of the door. The ability of force to cause a rotation thus depends on three factors. The magnitude F of the force, number 2, the distance r from the pivot or the axis about which the object can rotate to the point at which the force is applied, and lastly, number 3, the angle at which the force is applied. So lahat nitong three factors na to ay makita natin or naipakita dito sa figure. Lahat ng three observations or three factors na to ay pwede nating incorporate into a single quantity na tinatawag natin as the torque. Yan torque nga na yan is the rotational counterpart of the force. And torque is denoted as the tau. Ito siya. Torque measures the effectiveness of a force at causing an object to rotate about a pivot or a center. From this figure, for instance, mas malaki yung torque na ipinoproduce ng force 1, ito, compared dun sa torque na ipinoproduce ng force 4. Para mas maintindihan natin, let's take a look at another figure. Itong figure na to, pinapakita dito yung isang force. Ito siya, force applied at one point at a wrench that's loosening a nut. Ito yung wrench. And ito naman yung nut, yung hexagonal na yan. So, dinidefine dito yung distance r from the pivot to the point at which the force is applied. Ito yung starting point ng force, and ito yung r. Ito yung radius. And meron tayong tinatawag na radial line. Ito siya. So, yung radial line na yan, the line starting at the pivot and extending through the point. And the angle naman, ito yung angle. Say, angle theta na lang, measured from the radial line to the direction of the force. Nakita natin dun sa figure kanina, ito siya, that yung force 1, which was directed perpendicular to the door, ito siya, perpendicular, siya yung pinaka-effective para ma-open yung door. Yung force 2 naman, ito siya, directed toward the hinges, had no effect on its rotation. Another figure, dito sa figure naman na to, ipinapakita dito yung dalawang component vectors nung force dito. Ito siya. So, we have two components. Yung isa, force parallel dito sa radial line. Yung isa naman is force perpendicular dito sa radial line. Because yung force parallel, ito siya, either directly toward or away from the pivot or dun sa point, it has no effect on the wrench rotation. Hindi siya makakapag-produce ng rotational motion, and thus, wala siyang maiko-contribute dun sa torque. Only the perpendicular force, ito siya, tends to cause the rotational motion of the wrench. So, it is this component of the force that determines the torque. Yung force applied at a greater distance from the pivot has a greater effect on rotation. Kaya nga, dito sa figure natin na to, mas malaki yung torque na may bibigay ng force 1 kaysa sa force 4 kasi mas malaki yung radius niya from the pivot compared dito sa force 4. So, mas malaki yung value ng radius, mas malaki yung maipoprovide na torque. And we also saw that only the perpendicular force contributes to the torque. Nabanggit nga natin dito lang. Both of these observations are contained in our first expression for the torque. So this is our equation for the torque. Torque due to a force with perpendicular component acting at a distance r from the pivot. There is an alternative way para makalculate natin yung torque. So dito, ang ginawa natin in this figure is kinuha natin yung component ng force applied. Ito, component na perpendicular dito sa radial line, and yun yung gagamitin natin. So, force perpendicular times sa radius niya, ito. Another way is, pwedeng hindi na natin kuhanan yung component perpendicular doon sa radial line. Ito na mismong force na ito ang gagamitin natin. Kaya lang, ang mababago naman is yung position nung radius. Ito na yung gagamitin natin na radius. Yung perpendicular pa rin doon sa force. So, ito siya. Ito na yung radius na gagamitin natin. Perpendicular dun sa force. So, the line that is in the direction of the force and passes through the point at which the force acts is called the line of action. Yung perpendicular distance naman from this line to the pivot is called the moment arm. Or in other terms, pwede natin siyang tawagin as the lever arm. So, ibig sabihin, itong equation na to is pwede nating rewrite as the torque equals radius perpendicular dun sa force, and yung force naman na applied dun sa any object na i-analyze natin. The SI units of torque are simply Newton meters. Example number 1. A boy is trying to open a stock door. He pushes it at a point 0.83 meters from the hinges with a 250 Newton force directed 20 degrees away from being perpendicular to the door. The hinges are the natural pivot point. Determine the torque the boy exert and how could he exert more torque. So let's draw the figure. Say for example, ito yung door and ito yung hinge. And ito yung force na ibinibigay ng boy. We have a value of 250 Newton and ang layo niya from the hinge is 0.83 meters. So this is the radial line. So ito yung part na perpendicular ng force at ang layo niya dun sa pagiging perpendicular is 20 degrees. Now, kailangan natin yung force perpendicular kung ang gagamitin natin na radius niya is 0.83 meters. Kukunin natin yung component ng force na 250 Newton perpendicular dun sa radial line. So, ang formula natin for torque is ito. Torque equals radius times force perpendicular. Ito yung kailangan muna nating hanapin. Since itong component na to yung required para makalculate natin yung torque, force perpendicular, this is perpendicular, equals force cosine 20 degrees. Force perpendicular is equal to, we have 250 Newton na force applied, cosine 20 degrees. Force perpendicular is equal to 234.92 Newton. Ito ilalagay natin. Torque is equal to, ang radius na gagamitin natin is 0.83 meters times yung force perpendicular, ito siya, 234.92 Newton. By calculating, torque is equal to 194.98 Newton meters. So we have another question, how could he exert more torque? Yung torque ay nakadepende on how hard the boy pushes or where he pushes and what angle. Kung gusto niya maka-exert ng mas malaki pang torque, he could push at a point a bit further out from the hinge. Mas malayo dapat yung distance na pagtutulakan or pag-a-apply niya ng force, or he could just push exactly perpendicular to the door. Same position ng pagtutulak niya pero mas malakas na force ang kanyang i-apply. So this is example number 1. A worker uses a wrench with a length of 20 centimeters to tighten a nut, turning it clockwise. The wrench handle is tilted 33 degrees above the horizontal. If the worker pulls it straight downward on the end with a 120 Newton force, calculate the torque does the worker exert on the nut. So let's draw first the figure. Ito yung wrench. And this is the axis of rotation, and ito yung radial line. Yung force na 120 Newton is applied straight downward. Meaning, say andito sa point na to, directly downward yung 120 Newton na force. And itong wrench is naka-angle na 33 degrees above the horizontal. And yung length down ng wrench is 20 centimeters. Say, dito sa point na to mismo, naka-apply yung 120 Newton na binibigay ng worker. This is 20 centimeters. Now, we have to calculate for the torque. Gagamitin lang natin yung equation again. Torque equals radius times the force perpendicular. And ang force perpendicular muna natin is solve muna natin is equal to force times, ito yung perpendicular na force. And this is 33 degrees then. This is cosine 33 degrees. Force perpendicular is equal to 120 Newton cosine 33 degrees. This is equal to 100.64 Newton. Ito yung gagamitin natin dito sa formula. Torque is equal to, ang radius na gagamitin natin is 20 centimeters or 0.20 meters times, since pababa, ito yung ating signs, pababa yung force 120 Newton downward, this is negative 100.64 Newton. We put in the minus sign because yung torque is negative and it tries to rotate the nut in clockwise direction. So, negative nga siya. Torque is equal to negative 20.128 Newton meters. Now, kung gagawin natin yung alternative way to calculate for the torque, ang gagamitin na lang natin is yung mismong downward. Ito, kaya lang, ang gagamitin natin na radius is etong part na to. Ito. Mag-a-adjust lang yung radius, yun lang yung kailangan natin i-calculate. Torque is equal to radius perpendicular dun sa force na 120 Newton. Again, ang gagawin lang natin is yung 20 centimeters to calculate for the radius perpendicular. 20 centimeters cosine 33 degrees. This is equal to 16.77 centimeters. Ito ngayon yung gagamitin natin sa equation to calculate for the torque. Ang radius natin is 0.1677 meters times the force na 120 Newton. By calculating, torque is equal to 20.128 Newton meters. Pareho lang sila ng value. Sa una, ang in-adjust natin is yung force. Hinanap natin yung force perpendicular. Sa second solution naman, in-adjust natin yung radius. Hinanap natin yung radius perpendicular. Again, this is negative ulit. Kasi, yung torque acts to give a clockwise rotation. Both of the methods we used gave the same answer for the torque as should be the case. And this is example number 2. A person applies a force of 285 Newton at an angle of 54 degrees to the door 2 meters from the hinges, as we can see in this figure. Letter A, calculate the torque on the door, choosing the position of the hinges as the axis of rotation. And letter B, suppose a wedge is placed 1.5 meters from the hinges on the other side of the door. Calculate the minimum force must the wedge exert so that the force applied in part A won't open the door. So, sa part A, sa letter A, masasolve natin siya by simply substitution into the general torque equation. And sa part B naman, yung hinges, yung wedge, and the applied force all exert torques on the door. The door doesn't open, so yung sum ng lahat ng torques na yun must be 0, a condition that can be used to find the force ng wedge. So, let's start with letter A. We have to compute the torque due to the applied force exerted at 54 degrees. Ito yung force. and this is 54 degrees, ang force is equal to 285 Newton. So, gagamitin lang natin yung formula. Torque is equal to radius times the force perpendicular. Hindi perpendicular yung force na given sa atin dito. So, kailangan pa natin siyang hanapin. Ito yung force perpendicular. And directly na dito sa ating equation, radius times force perpendicular is equal dun sa force times sine 54 degrees. Torque is equal to, ang radius natin is 2 meters times force 285 Newton sine 54 degrees. By calculating, torque is equal to 461.14 Newton meters. For letter B naman, we are asked to calculate the force exerted by the wedge on the door on the other side of the door. And to calculate, dahil hindi nagagalaw yung door, ibig sabihin, wala na siyang magiging motion. Zero na yung kanyang total torque or yung kanyang net torque. So, paano ba yung mag-zero yung net torque na yun? Say, for example, ito yung net torque. Again, as I have said sa explanation natin kanina, yung torque is just the rotational counterpart of the force. So, meron tayong net force. Pag pinag-add natin lahat ng force sign is zero. Ibig sabihin, wala na magiging motion. Hindi nagagalaw yung door natin. Kaya lang, kailangan hanapin muna natin lahat ng torques na yun. Unang torque is yung torque from the force applied, torque F, plus yung torque dun sa wedge. Say for example, nandito sa position na to yung wedge. This is a torque wedge. Siya yung kukontra dun sa door para hindi mabuksan. This is torque wedge plus yung torque ng hinge, which is 0 kasi nandito siya mismo, wala siyang radius, 0 na agad dito. And again, 0 lahat ito kasi hindi na siya magkakaroon ng motion, 0 na lahat yan. So, para ma-solve natin yung force ng wedge, again, yung wedge is applied 1.5 meters ang layo dun sa hinge. Say, this is 1.5 meters. Again, using this equation na 0 yung net torque, 0 equals yung torque ng force applied is 461.14 Newton meters plus yung torque ng wedge, radius ng wedge, we have 1.5 meters times yung force ng wedge. Ito yung force ng wedge, pag ganyan siya. Kasi pakontra siya dun sa force applied, siya yung pipigil dun sa pinto para hindi na gumalaw or hindi na mag-open. Plus yung radius ng hinge times that force ng hinge, which is 0 na to. So, using this equation, masasolve na natin yung force ng wedge. Positive ito, and ang negative natin is yung force ng wedge. So, this is negative. 0 equals 461.14 Newton meters plus radius times the negative force ng wedge. And solving for the force ng wedge, lipat natin sa kabila. R times positive na siya, force ng wedge equals 461.14 Newton meters. We divide both sides by the radius ng wedge. Force ng wedge is equal to 461.14 Newton meters over, ang radius is 1.5 meters. Cancel yung meters. Ang matitira is Newton. 461.14 divided by 1.5 is equal to 307.43 Newton. Again, yung force sa hinge ay hindi nagpo-provide ng torque kasi yung radius na ay nandun mismo sa axis of rotation, 0. And yung wedge force naman ay nag-act mismo 90 degrees. Ito siya. Perpendicular na agad, opposite dun sa upward na force applied. Mapapansin natin that yung angle from the position vector to the wedge force is, again, pababa. And that's because, starting at the position vector, it is necessary to go 90 degrees clockwise, yung negative angular direction, to get to the force vector. Measuring the angle that way automatically supplies the correct sign for the term of the torque. Alternately, yung magnitude of the torque can be found and the correct sign chosen based on physical intuition. So this is example number 3.